So thank you, Stefan, for the welcome in the introduction. Maybe first I should shortly introduce myself. So I'm Peter Lutz. I'm responsible for this field level communications initiative, bringing OPC to the field level. So I will guide you through the program that we have in the next maybe still 75 minutes. That's the plan. You see that I will first of all introduce overall in the goals, in the, let's say, approach, how we want to bring OPC to the field to meet all the requirements. We then have different presentations from different supporting companies, looking in use cases, looking into some of the enabling technologies. You see TSN, it's one enabler. I will explain in my intro that there are other enablers as well. And we will also have a live demo and getting information how finally to get something implemented if you don't want to start from scratch but use existing tools or toolkits. At the end we will have Q&A. Maybe we can also do this in between. Let's see how the speakers keep to their 15 minutes. This is maybe the dependency. And important is that after we finish, we will have lunch. Because we understood lunch is a little complicated here in this room and officially not supported. We will have the lunch up in the room 3A. This is 2 floors up. This is actually the same place where the cloud conference will be at 1 o'clock. So those of you that would immediately like to stay for the cloud conference are already at the right place. And this is then 12:30 to 1 o'clock. So this is the plan. Those that potentially did not register for the conference should at least leave their business cards, because then you get a link with all the material, PDFs, video recordings, and we have you also in our database. So don't forget this. Okay, with that, I'm going to get started. And first, like to show you, so to say, the big picture. Not the big picture like Stefan did with talking about also cloud. So I will really concentrate on what are we doing to meet requirements, use cases in the field level. So before I get started, just a short intro about using terms, because we still have some confusion around that. We use FLC. When we use FLC, we talk about the organization, the initiative working groups. This is a term we used since 2018. But important is whenever we talk about the technology, all the extensions we do to OPC, this is where we use OPC FX, FX standing for Field Exchange, or the short form UAFX. And the funny thing is, and still people get confused, the UAFX short form is without a blank, the long form is with the 2 blanks. That's just an intro. And we try to keep this consistent. All right, so let's see. What does it mean for us bringing OPC down to the field? You see some of traditional use cases here with numbers 1 to 4. So when we started the FLC initiative, it was clear we need to go into areas that OPC has not covered before. For this, we have to deal with deterministic behaviors, not only necessarily real-time overall for an application, but also deterministic transport. And then certainly have a safety solution in place in case you have a safety-critical operation. And then all the different use cases and application areas like motion control, remote IOs, or instrumentation. Because as you have seen and heard from Stefan, we do a harmonized approach. That means we are not developing a solution for, let's say, factory automation only, but the solution also fits to process industry. And we have even other domains outside like energy, projects and applications where the same concept also can be applied. So it's a generic approach. And even we had the 5G as a separate use case not included at the beginning in FLC. We now deal more and more with 5G. So this is why you see the orange frame around. So the 5G integration is now part of the concepts we develop. And important, maybe a quick note on the numbers 5 and 6. The agreement was we are not doing all the use cases in one step, but start with the controller to controller first, the number 5, and then move into really the field, which is the connection to all the field devices where we have field buses today. This is number 6, C to D and D to D. And the overall goal that Stefan was talking about, and that is certainly I think one of the key value propositions of OPC UA FX, that it's not becoming a field bus, because FX is built on OPC UA. That means we will have a universal network that fully scales. So that means in this abstract graphic, all these interactions, whether it's between controllers, whether it's between controller device, between devices, or up to any kind of what we call compute function, edge, cloud, any kind of software application, this is all done consistently with OPC UA. So you're not losing this connectivity, but it's always included. And it's also included the security that is built in OPC UA. So these are the key factors to make this, let's say, a different solution that some think we are just developing yet another field bus. That's not the case. Scope of the FLC initiative and for OPC UA FX is certainly the bubbles down there. But as I said, the interactions up, they come immediately when bringing OPC UA FX in the devices. Then you have this connectivity up included with all the information that is made available. Now, how does this look like when we look more in the landscape, how automation is done today and in the future? You see on the left-hand side how the traditional approach today is. You have OPC UA from the controller up. You have different field buses, certainly too many field buses, going down into the field level. And now we are changing this with having OPC UA FX included. That means in the first step, as mentioned, this is what we call internally the phase 1. We deal with this cross communication between controllers, but it's including real-time data exchange. And then in the next step, you see this on the right-hand side, we extend, it's more an internal phrasing, the phase 2, to then include C to D as well as D to D. And then with that, we have a consistent solution based on OPC UA, but certainly you still have to the left the possibility to migrate from brownfield installations, including a machine that in the first step might not support FX. You still can, let's say, connect the controller into an OPC UA FX infrastructure, whereas the machine itself remains with traditional bus systems. So this is all possible. So vision for the future is certainly to move into the ecosystem you see on the right-hand side. And this is then actually really converting the traditional approach with this famous automation pyramid into this fully flexible information exchange. We call it information network, where you can also share different kind of information between IT and OT. And that does not mean this is one network, and it's certainly not unsecure. It's clear this is secured, and you still have network segments. So some are a little shocked to see that this is now all linked together. But you see in the background also these frames. That means it doesn't mean they all run in one network. That would not be possible and not be feasible. But you understand, I think, the vision that we have. Ideally moving information from the source to the destination without changing the semantics, without changing protocols, convert that, but have direct access. Now, a little detail on the initiative itself, but I'm not spending too much on that, but we have established for this project a steering committee with supporting companies, currently 23. It's something like the board that we have for this initiative. They take decisions on the roadmap. They certainly approve the requirements for the technical work, but then the technical work itself is done by any OPC Foundation member that is interested, and you see here the numbers. We have 10 working groups in place. We have more than 80 OPC Foundation member companies represented, and overall more than 270 experts currently active, either with contributions or at least monitoring in the technical work. So we're really having a big wheel that we are turning. Okay, and now just give you an idea what is the technical approach. Not too technical, I also have to keep to my 15 minutes. But this shows, I think, well, what is the overall technical approach. You see in the blue box what we use out of the OPC UA toolbox, so to say. What is existing in OPC UA? This is the framework, including the client server. This is what we need in order to set up all the real-time connections. We use the pub/sub, which is the basis for enabling the real-time data exchange cyclically. We include safety in case you have a safety-critical operation and you need functional safe communication. The built-in security, one of the key aspects why OPC UA and OPC UA FX is so attractive. And the base models, on top of them we create then our own models for the different controllers and devices. So what we are adding is the orange part. This is then, as I said, information models and behaviors for the different devices and controllers. Certainly how to configure the system. This is part of the orange frame. And this is then what you combine with all the existing or future companion specifications, the models that are built for different machines, applications, such as VDMA working groups, but also around the world, building semantics that can be combined with OPC UA FX. And then, extremely important is the green part, because we are not creating, as I said, a field bus where you have a specific chip that you need to integrate. We are building on open standards out of IEEE, out of 3GPP, and we are completely flexible because of our layered stack architecture. We are not bound to just 100 megabit Ethernet or whatever. We really can easily adapt and be flexible. This is why we have some enablers that help us to bring OPC UA FX into the field, and I have some additional slides on the key enabling technologies a little bit later. What is important is the right box. The certification that has been agreed at a very early time is a mandatory step vendors need to take when bringing OPC UA FX products to the market. So far, OPC UA has a voluntary certification, but because OPC UA FX is dealing with critical operations in machines, in skids, it was clear we have to get the certification done, and this is why anyone that wants to promote now a controller or later a device with OPC UA FX has to undergo certification. For this we have a program in place, we have a testing tool in place, so it should hopefully not be too complicated to get vendors through this process. Now talking a little bit about the key enablers. One key enabler is Ethernet APL, the advanced physical layer, because this brings Ethernet into the field devices in the process industry in hazardous areas. And by bringing Ethernet into these devices, we can also bring OPC UA and OPC UA FX into these devices, like you can do with other protocols. So this is one key enabler. The other key enabler which is maybe more the focus of this conference today, is time-sensitive networking, Ethernet TSN. This is a key enabler on the one hand side to enable this deterministic transport, and we will hear later how this is done and what features we use. But it's also a relevant technology to finally come to this IT-OT convergence, allowing protocols to coexist and go away from these dedicated, closed networks we have today to a more open, a more flexible structure in the future. So TSN has different aspects that are highly relevant for building the OPC UAFX ecosystem. Another enabler is, as I mentioned before, the OPC UA safety, which is available as a specification since quite a while, and we are hopefully soon having a safety testing tool and also a safety stack that companies can integrate available. And this is built on top of the OPC UA communication, and it's independent of actually what stack you use. That was one of the requirements to build this software. And it's the same approach that you have today with other safety protocols in the market, like, for example, a ProfiSafe. And we cannot dive into details, but you also find here some information in our YouTube channels or on the OPC Foundation website. And this is, I think, now one of the use cases that shows the, let's say, the flexibility an OPC UA solution with the FX extensions has, because this is actually a combination of all the different enablers that I showed before. It's showing mobile robots that are connected to stationary robots. So we have the aspects wireless and wired in this application scenario. It's a safety critical operation. So that means we have to have OPC UA safety in place to protect man and also the robots somehow. It's controllers that certainly control the robots. That means we have here controller-to-controller scenario. And also we are routing then end-to-end information across this, let's say, network, first going wireless from the mobile robot into a wired network infrastructure, into the stationary PLC. And these things are easily possible with following the approach that we take with OPC UAFX. Now let me talk at least for a few minutes about where do we stand, maybe most interesting question overall, because it's nice to see how this is all done, but you want to know where we stand and what is ahead. So let's first talk about what has been achieved. We have completed the complete specification that we need for the use case controller to controller. This is done. We have a smaller revision that will be published in May, but this is not stopping anyone from doing anything. We have included in this already all the base concepts we need to have for the next step, which is controller to device and device to device. So this is already included. All the base concepts are part of this completed work. And then very important, we have become the agreement, or got the agreement with all the key automation suppliers to agree on exactly one controller profile. So this is, let's say, the construction description, how to build an OPC UAFX compatible controller. And there is exactly one. This is why I said it's a generic approach. It can be any kind of controller, PLC, a DCS system, a robot controller, whatever. And this is also completed, agreed. And then the final step is also done. We launched the certification program. That means you can today bring your prototype to the lab and get this controller certified to bring it to the market. So this is a clear statement that for C2C check mark, this work is done. And now the road ahead is what is ongoing work. It's not started just now, but it has been started sometimes for the motion group, for example, already 4 years ago. We are now extending the existing specifications, so what some call specification enhancements, to cover the additional use cases C2D, D2D. We have some additions to the spec with regard to, for example, parameterizations, how do controllers parameterize all the field devices, how to do the bootstrapping, how to, let's say, boot up the complete network with controllers and field devices, and some enhancements to the networking that we need for some of the more sophisticated application areas. And then certainly we will, like we did for the controllers, develop the profiles for the different types of field devices, whether it's an instrumentation device, whether it's a motion device, an I/O device, or like here at the show, we had some interest of vision system manufacturers, where for sure it's also interesting to create a profile for these kind of devices. And then certainly we will enhance the certification program at the time we are ready with that, with the specifications, to then also offer certification for field devices. What you see since quite a while, and we have it also here at the show, is this, I would say, famous demo wall where you see a lot of PLCs, DCS systems from different manufacturers that have, at least to a high percentage, I would say approximately 50–55%, already implemented FX as prototypes. So we can demonstrate how easy it is to bring them together in what we call production lines in our demo. And the others that have not yet built their prototypes can, and we will see this in, I think, one presentation later on, how to migrate from their existing controller, including OPC UA, up to an OPC UA FX controller. So there are just features you need to add, you need nothing to throw away, and this is why we can really expect that all those that offer OPC UA today with their PLCs, and I think this is supported by all the manufacturers around the world, they can easily migrate up to OPC UA FX. This is the great potential for us. Once they have done this, the next step to support C2D is also a minor step, and this is how we want to, let's say, grow our ecosystem to build something which is really completely independent, all the major suppliers on board. So this is the dream that will become reality. So this is an example how we demonstrate bringing together different PLCs. In this user interface, you see we can select which controllers to combine. They are then connected with each other. And this time, for the first time, as Stefan mentioned, we also include remotely a PLC on the booth of the 5G ASEA. It's in Hall 14, it's quite a distance. And we integrate this controller using a 5G connection. You see here the Mitsubishi Electric 5G device, and you just don't recognize that this is a remote control. So this allows a lot of flexible applications to be realized. And you can have certainly a look at that. We have also video cameras showing that this is really a live demo, and we are reacting in real time what the other side is doing. Okay, that leads me to, I think, one of my last slides. This slide is just about what documentation you find if you not want to immediately dive into the specs, but we have different collateral. There are also cards at the end where you have these QR codes to easily get the digital brochures, and we also certainly have printed ones at our booth in Hall 9. And finally, my contact details, and this is all from my side. Thanks for your attention, and I think I kept almost my 15, maybe 20 minutes. With that, I hand over to the next speaker.